Hi and welcome to this video tutorial in which I will be taking you through the working out and the answers of the June 2017 Foundation Year Paper 2. So without any further ado, let's get started. So question 1, it is a question on algebra and simplifying. So let's do that. Part A should be straightforward. We have 5p minus 3p, that's 2p plus 1p, that is going to be 3p. Right? Question B, or part B, sorry, m cubed plus m cubed, that's so easy, 2m cubed. Simplify, part C. We've got numbers, and we've got term C, and we've got term D. Right? The number itself, it doesn't collect with any other numbers, so that's on its own. 3C minus 4C, that gives you minus 4C. 5D plus D, that gives you 6D. Right, moving on to question number 2. Write 56.78 to two significant figures. This is the first, or the significant figure is this one, 5, but it is followed by 6. It is more than halfway, so it will round to 60. That's your answer. Next question is question 3. Alright, question number 3. Alright, we have a bar chart, a frequency diagram. Part A, the diagram or the bar chart represent, the students year 6, the type of transport they use to get to school. Okay, and we have the key here. The grade one is the boys and the striped one is for the girls. I can notice there is one missing here, so probably there is a question asking us to fill in that or to draw that bar for the girls here. Let's do the part A. What is the most popular type of transport used by the boys? The boys is the grey, okay, and the most popular means the highest bar. And the highest bar is this one, which correspond to walking or walk. Okay, 7 girls walk to school. We need to show this on a dual bar chart. Okay, so 7 girls walk, so it's walking. 7 is here. Let's draw it with the ruler and draw the stripes. Okay, like so, and that's done. Okay, so part B done. More of the students get to school by car than by bus. The one who says students means boys and girls. By car, so that's by car is this one here, and by bus is this one here. So we need to add up here. That is 5, and that is 9. So altogether is 14. Minus, for the bus, you got 6 and 4, that's 10 altogether. So that is by 4. Okay. The number of students in year 5 is the same as the number of students in year 6. Now for this dual bar is for the year 6. Alright, we haven't got year 5, but they're talking about year 5 here. So what do they mean? Okay, let's find out. Year 5 is the same as the number of the year 6. What is the total number of year 5 and 6? All right. Now, so what I have to do is just find the number of year 6, of students in year 6, and times it by 2. Okay? Right. So if I do this one 5, 9, I've done this first 2. Do this one here, that is 9. Basically add up all the frequencies. This one is 7. I'll write it down here. This one is 4. This one is 1. This one is 2, this one is 1. So we've got here 3, we've got 5. All right, I circled them. We got 16. We got 10, and we got 14. So basically, we're going to do 14 plus 10 plus 16, all the circled ones, plus 5, plus 4. The 3, no, sorry, about 5 plus 3, I apologize. Right, so 4, 6, 10, 10 and 8 is 18. Carry the 1, 1, 2, 3, 4. Times it by 2 is 96. So the answer here is 96 students in year 5 and in year 6. All right, next question is question 4. Right, question number 4. We have 4 fractions. We need to put them in order of size, smallest to largest. When you are dealing with fraction and you need to be putting them in order, you need to find a common denominator. In this case, you can see clearly the common denominator is 30, right? So, we're going to do the first one. To get this one from 5 to 6, sorry, to 5 to 30, we need to multiply by 6. So that I get 12, all right? Out of 30, of course. This one here is still the same. Doesn't change because it's already out of 30. This one here, it times it by 15. Right, so you get 15 out of 30. This one here, it times it by 2. Okay, you get 14 out of 30. Now, all you have to do, just compare or put the numerators in order. The smallest one, it's this one here, 11. Okay, he says start with the smallest. So that one, 11, is this one here. So we're going to put 11 out of 30, comma, and let me cross it from there. Next one is going to be 12, which corresponds to this one here. All right, so it is 2 over 5. You see what I'm doing? I'm writing the original fraction before it was converted to out of 30. Cross it from here, cross it from there. And you got 14 before 15, and that corresponds to this one. So it is 7 out of 15. Right, and then we got the last one, which is a half. And that's the answer to question 4. Next question is question 5. Right, question number 5 is on tallying or tally table and pictogram. The question asks us what is wrong, okay, A and B. Now I went ahead and did question part A, the frequency for Monday. You can say if you counted the tallying, you find it's 13, but they wrote it down the frequency as 12. It should be 13. Right, let's move on to part B. Right, the key says the circle is represents 3 CDs. Now if I look on Tuesday, it means that I got 15, right, according to this pictogram. All right, but if I look here, Tuesday, it should be 18. So it will be one circle should be drawn. Okay, one circle should be drawn. Okay. All right, next question is question 6. All right, question number 6 it is a question on money. We have a third of the coins, right? In the bottle, we have 495 coins. Some of them are £1, some of them are 50p, but some of them are 20p. But we know a third of the coins are £1. What's the total of the £1 coins? So we need to do 495 divided by 3, right? And the answer give you 165 1-point coins. So that gives you 165 pound. Now for the 50p, now it's 124. So that is 124. Okay, we times it by 0.5. You do that in your calculator and you get the answer 62 pound. Okay, it says the rest of the coins are 20p. So we need to do 495. We need to work out how many 20p coins we have. So we need to do 495 minus 165, the number of £1 coins, and minus the number of the 50p coins. And if you okay, I'll do that in the calculator right now. Minus 165 and minus 124. That is 206 coins. Alright, so we need to multiply them by 0.2, okay, to get the amount of these 260 20p coins. If you do that in a calculator, you get £41 and 20 pence. You add all the three figures because the question asked me the total value of the 495 coins. So we need to add this one, we need to add this one to this one to this one. So let's go ahead and do that. So it's going to be plus 62 plus 165, and the answer is £268 and 20 pence. And that's your answer. Next question is question. Alright, question 7, and we're going to do question 8 together. So question 7 is on probability. It says the probability that a new fridge has a fault is 0.015. What is the probability? What is the probability that the fridge does not have a fault? Right? You know, to work out the probability that the fridge has not a fault, you do 1 minus 0.015. Alright? Do that in the calculator. 1 minus 0.015, and the answer is 0.985. Okay, give it as a decimal number. The calculator may give it to you a fraction, so go ahead and press the SD key or button. Right, question number 8. We want the numbers that are square, so we want to list the number squares. All right, we have this one is square number 25. Do we have another square? 21 is not. I'm just checking. No, that's only one. 25. We want to write down a multiple to both 4 and 6, and that number is 24, because 24 divided by 4 is 6, and 24 divided by 6 gives you 4. So the answer is 24. All the prime numbers. 21 is not, 22 is not, 23, 29. So 23 and 29. All right. Next question is question 9. Question number 9 is on angles with algebra. Now you know the angles at a point or around a point add up to 360. You know this is 90-degree angle. So basically we're going to have to do the equation when you do 2x plus 3x plus 90 equals 360. So this is 5x, this 2 here. Alright, and then we minus the 90 from both sides because I want to solve it for x and then find the value x. Okay, we'll solve it for x. So 360 minus 60 is 270. Now x equal, you divide both by 5 now. So you get 270 divided by 5. Do that in a calculator. It is a calculator after all. And the answer is 54 degrees. Alright. Next question is question. Right, question number 10. We have a question on envelopes. Suha is going to buy 150 envelopes. We want to find the best buy. Got two different offers in the shop, or two different shops. letters to send says pack of 25 envelopes for £3.59. Now, if you did a calculation, she wants 150 envelopes, and this shop here, a pack contains 25 envelopes. So how many packs she needs to buy? If you did that, she will need 6 packs. All right. Okay, we're doing the this one, of course. So basically, we need to do 6 times £3.49, and that gives a price of £20.94. That's right, £20.94. All right, let's do the stationery world. They have an offer, a pack of 10 envelopes for £2.10. Basically, with this shop, she's gonna need 15. She do 15 packs. 150 envelopes divided by 10. Envelopes come in packs of 10 envelopes. All right. Sorry, envelopes come in packs of 10. That gives you 15 packs. All right, guys. So basically, the offer is you buy 2, you get 1 free. Let's do all the calculation. 2 plus 1. All right, that's 3. You buy 2, you get 1 free. So you got another 3. You buy 2, you get another 1. So that's 3. I'm counting up until you get to 15. All right, that's what you do. All right. That's a different one. You could use ratio, okay, because 2 to 1, you divide 15 to 1. But I just want to do it this way. All right, 1, 2, 3. So far we've got 12 packs. Remember, she needs 15 packs. And so basically, she needs another 2 plus 1. 1, 2, 3, 4, 5. 5 times 3 is 15 packs. Now, each one of them, because she's buying 2, right, she get the third one free. So she only paying for 2. He or she, yeah, buying for 2 packs. That goes out times it by, sorry, not times it, I apologize. She pays for 2 packs, means that it will cost her £4.20. And because I have 5 of them, so you multiply by 5. And you do the calculation in your calculator, you get £21 is the answer. So you can see clearly letters to send is a better value. Okay. Right, so you should buy it from this shop here. Right, to show the answer, letters to send. All right, so that is question 10. Now, next question is question 11. Right, question number 11, part B. It is asking us, sorry, part A, I apologize. Question 11, part A. I went ahead, I did the line that goes from 74, because we want to change 74 centimeters to inches. So you need to find the scale. It's very important. That is 70 there. Okay, the 70 is there. So it goes up in 2s. Okay, 72, 74. All right, you need to get that right. Now on the horizontal, on the inches axis, it goes up in 1. Okay, so this is 10 inches. All right, each millimeter is equal to 1 inch. So basically this is 29 inches. All right, that's the answer to it. Okay, now for part B, we have the height of Daniel's, which is 6 feet 3 inches, and we've been given the conversion rate between foot and inches. 1 foot is 12 inches, so 6 feet would be 72 inches, right? You do times by 6. So basically, Daniel's height in inches is 72 plus the 3 inches there, altogether 75 inches. Now on the graph, we've been given the conversion graph. The inches axis goes all the way to 50. Now, how do I get around that? Well, 75 is divisible by 25, so we could do 25 inches first, all right? So which I did here, so that is 25 inches. Read the conversion into centimeters. We change it to centimeters. That gives us 64, okay, centimeters. Now, how many 25 into 75? You times it by 3. You times it by 3 here to get 75 inches. And I give you 64 times 3, which is 192 centimeters. All right, so Daniel's height in centimeters is 192 centimeters. All right, next question is question 12. Right, question 12, it is a calculator question. Basically, you need to have your scientific calculator and enter all these calculations and write down all the figures that your calculator displays. All right, so we're going to switch screen to this calculator here. We're going to use the fraction. I mean, yours will look different than mine and then this one here. This is an online calculator. You start by, but the procedure is the same. You would start by entering the fraction function there as it is, okay, and you enter square root and you enter the numbers. So you got 13.4 minus, within minus 1.5, and then we jump to the denominator where we open the bracket. So you write it down exactly as you see on your exam paper. 6.8 minus, or plus, should be plus 0.06, and then close bracket and square, and then you go back to here and you press equal, enter, and that is your answer. So the answer is 00. If I could copy this, I believe I can copy. No, it doesn't do that. Okay, but the answer, I'm gonna go back to my board, right, and I'll write it down. I got it in my calculator anyway, but just to show you how you do it. So the answer is 0.07330359081. All right, that's what my calculator displayed. That's what you should display, everything. Don't leave any digit, everything. Do not write down ... and so on, because that's what it says here. Display all the figures, all right? Question 13 is a rotation question, clockwise, so you should go this way, right? Okay, that's the clockwise, all right? So you do it 90 degrees, use a tracing paper, and you should get this shape, right, with these coordinates, okay? Exactly like this, right? Next question is question 14. Sorry, it's not question 14, it's question 13b. It says describe fully the single, it is one transformation only, that maps B onto C. Right, you can see clearly it is a reflection. This is an image of this one. Right, so it is a reflection. You need to say reflection. Sorry guys. Reflection in the y-axis, okay, or x equals 0, right? You can say x equals 0 means this y-axis, right? And that's what I've done here. It means your mirror line is the y-axis. That's what it means. Okay. So now it's question 14. Right, question 14 and 15 together. All right, let's start with question 14. We need to factorize 5 minus 10m. Now you can say the common factor is 5. Right, so we're going to do 5 outside the bracket. should be 1 here, because 5 times 1 will give me 5. This one here, minus, and then you need 10. So that's 2m, because 5 times 2m gives me 10m. Right? That's how we do it. We need to factorize fully this one here. You can see there is a and b, and there's the 2. Right? So it's going to be 2ab, right? And it's going to be a plus 3b. Double check by expanding, right? So we multiply this by this, 2ab times a, 2ab times a will give you 2a squared b. A and a, or a times a give you a squared, plus 2ab times 3b will give you 6ab squared. So it is correct. That's how you do it. Question 15a, 4.7 times 10 to the power minus 1. We need to change it to an ordinary number. So you do 4.7 divided by 10, because 10 to the power minus 1 is same as 1 over 10, which means you divide by 10. So basically the answer is 0.47. Question B, you multiply the decimal numbers together, 9.5 times 2.4, and for that you get 22.8 on your calculator. And then you do the power part, 10 to the power 3 times 10 to the power 5, which give you 10 to the power 8. Now you need to put the two together, 22.8 times 10 to the power 8. That's the answer, but we need to convert it to a standard form. So we need to divide by 10 here, and we need to multiply by 10 here. So the answer as a standard form is 2.28 times 10 to the power 9. Right, question number 16 is a question on loci. So we've got 3 points A, B, C on a map, and we have a scale 1 centimeter represent 100 meters. So 250 meters will be represented by 2.5 centimeters. You divide by 100 to get 2.5 centimeters on our map. So the first thing we need to do, I'm going to do, is the second line where it says equidistance from B and C, right? First thing I also would like to do is join B to C with straight line. Okay, and then I will grab my compass. Right. Put the pointer on B. You can start from C if you want to. Good thing is to open your compass as wide as possible and draw a nice big arc. Alright? And do the same thing on the other side, keeping the pointer at the same point. So I'm going to do another arc. See, I haven't moved the radius or of the compass. Okay, so now I'm going to move the compass. I'm going to put it on C with the same radius, of course. So I'm going to do one arc here, there, see they intersect, and then do the same thing on the other side. I can see they will intersect there. Right, I'm going to move my compass away, and with a ruler and a pencil in your exam paper, in my case I use this tool which allows me to draw straight lines. So you just join the two intersections, something like this and this one. In the exam you need to keep all the arcs, all the markings. All right, these are part of your working out. Do not rub them off. Right, I'm not sure I need that ruler, so I may need to dispose of it, but I'm going to leave it there. Okay, but I would need the compass still. I need to go back to point T is 250 meters from the point A. I didn't read it properly, sorry. Point T is 250 meters from the point A. That is the point A. So we need to draw a circle around A with a radius of 2.5 centimeters. So let's do that. The problem with my compass, as you can see, it does not go smaller than 4 centimeters, right? The smallest radius will give me is 4. So I'm going to draw it with 5 just to illustrate. Okay. That's what you do, but you should have yours at 2.5 centimeters. It's quite small, to be honest, to have a compass at 2.5 centimeters. They should have said something like 4 or maybe 3 centimeters or 3.5 to make it more manageable for the compass, that is. So now you've got the compass pointer on A, so that A will be the center of your circle which you are about to draw, like so. Okay. So now you can see the second point is, the circle intersect with my line, this one here. And so where the two intersect, the point T should be there. Mark it with the letter T. There is another one there, possibility, right? But I only want one. It says, on the map, show one of the possible position for the T. It's this one here. All right, but again, in your paper the circle should be smaller than this for the reason I explained. Okay, I hope this helped. Next question is question 17. All right, question number 17 is a question on probability. So we have a dice that has been rolled 200 times, and these are some of the recordings. We need to work out the probability of landing on 1. To do that, you need to add all these probabilities and the sum, you deduct it from 1. So let's do that. Probability of 1 equal 1 minus, and you add all these, plus 0.18 plus 0.09 plus 0.15 plus 0.1, and the answer is 0.31. Okay. We need to calculate an estimate of the total number of times the dice will land on a 1 or on a 3. Let's do probability of landing on a 1. You do 0.31 times 200, which gives you 62. Probability of landing on a 3 is 0.18 times 200. It's going to be 36. You add the 2. That's 8, 9. So that's your answer. 98 times. Okay, altogether. Right, question 18 is a question on ratio, fractions, and some percentages. Go ahead and read the question for yourself and follow my working out. Now I'm going to do adults, right, and children. Write down the ratio, which is 5 to 2. As a fraction, adults represent 5/7 and children represent 2/7. Now here he says 3/4 of the children had seats in the stalls, but also we've been told 117 had seats in the circle, so those 117 represent 1/4. Okay, so basically the total number of children would be 117 times 4. Okay, and that will give us 468. Now that 468 represent the fraction here, 2/7. So basically 2/7 is equal 468. So you can go ahead and do 1/7, which is you divide by 2. And that gives you 234. Now to work out the total number of children and adults all together, you need to multiply this by 7. So that is 2, 3, 4 times 7. And that will give you 1,638. Alright. Now the question says, is this number here 60% of the seats? Does it represent 60% of the seats? Now there is one way I'm going to do this is I'm going to take 260 seats, because that's how how many seats in the theatre. So 260, and I do 60% of it. Okay, so I divide it by 10 first, which gives me 260, and then times it by 6, and that will give me 1,560. Now you can see the total number of children and adults is greater than this number. 1,638 is greater than 1,560. So the answer is yes. Alright? And we're showing the working out. Next question is question 19. Question 19 is a question on plans and elevations. So we've got this 3D prism. We need to draw it as a 2D. We need to draw the front first, and we draw the side. Right, very important to know that the scale we're using, 2 centimeters, represent 1 meter. So if I got 2 meters here, let's write down first the scale, sorry. Write down 1 meter represent 2 centimeters in our drawings. So 2 meters, I would represent it with a side or drawing of 4 centimeters. And 0.5, like this one here, 0.5 meters, I would represent it with a drawing of 1 centimeter, because you just multiply by 2, right? Okay, so let's do the front first. So this one here should be 2, sorry, this one is 2 meters, it should be 4 meters. Sorry, I apologize again. This one is 2 meters, it will be drawn as 4 centimeters. Let's do that. So that it's going to be like so. Each grid is 1 centimeter long, and you've got a height of 2 meters, so that is another 4 meters up. Okay, we've got a half meter here, so that will be a 1 centimeter drawing, and then you join the 2 ends, and then you label your drawings. This one represents the front. Okay. Now for the side, you got this rectangle here, which is 1 meter, in this case 2 centimeters, and you've got half a meter high, which is 1 centimeter, and then box it in. Now you also have this rectangular with this slant here, which is going to go all the way up to here. It means it goes all the way up to here against the front drawing. So it's going to go all the way up there, and of course it will be the same width. It is 1 meter wide, like so, and that's how you do it. Next question is question 20. Alright, question 20 is a question on speed. We have Ollie, who drove from Liverpool to Manchester. I illustrated the diagram here with all the information needed. Alright, so Liverpool to Manchester is 56 km or kilometers. Manchester to Sheffield is 61. Now the speed he was driving with from this Liverpool to Manchester is 70 kilometers per hour, and the time it takes him to travel from Manchester to Sheffield is 75 minutes. We need to calculate the average speed from Liverpool to Sheffield. In order to do that, you need to work out the total distance and you divide it by the total time, okay, because the formula, you know it, S equal D, or distance over time. So therefore the time, sorry, is distance divided by speed. You switch these two around, okay. Now for the first phase, if I want to calculate the time it taken him, I need to do that to travel from Liverpool to Manchester. I need to do 56 over 70, and that would give me 0.8 hours. Check that in the calculator, of course. Now we've got a time here in minutes. In the second phase, we need to convert that into hours. That's easy. You do 75 divided by 60, and that will give you 1.25 hours. You need to add the 2. Okay, so we do 1.25 add 0.8. That gives you 2.05. Okay. Now the total distance is 56 plus 61. So 56 plus 61. That gives you 7 and 11, 117. So the total, or the average speed, is going to be 117 divided by 2.05. Plug that in your calculator and you got something like this, 57.07 and so on. You need to round it. It doesn't say, but round it to 50. You can leave it like this, that's fine. But I would round it to 57 kilometers per hour. And that is, I used two significant figures. You need to say what degree of accuracy you have used. All right. Next part is part B of this exercise. All right. Part B is about an assumption. Janie says that to calculate the speed from Liverpool to Sheffield, I think you have to, all it needs to do is to do the mean of the two speeds, 80 and 60. Now, the assumption he's made, or she made, is that the time taken to travel from Liverpool to Manchester is the same time to travel from Manchester to Sheffield. Okay, so we're going to write down here. Okay, assumption. Well, Janie assumes that the time in both phases is the same. All right. Next question is question 20. Sorry, just go back to this one here. It said I realized I made a mistake, not in the assumption or the conclusion. It's just in time in both phases. So I should put both phases here. Let me just write it down like this. Both phases. Okay, that's all. Next question is question 21. Question 21 is a question on similar triangles. So I like to draw them separately. The bigger triangle, A, E to C, and the inside or inner triangle or smaller triangle, D, D, B, C. Now you can see the corresponding sides, E to C and D to C. We're going to use these two to work out the scale factor. So the scale factor, you always do the bigger divided by the smaller. In this case, 8.1 divided by 5.4, and that gives you 1.5. So therefore, to work out A to E, we need to multiply because we're going from small to large. These two are corresponding. So we do 2.6 times 1.5, and that will give you 3.9, and the unit is centimeters. All right. Question B, it says work out the length of A to B. to B, right? So I need to work out B to C because that is corresponding to A to C. So I need to do 6.15 divided by 1.5. That will give me 4.1 centimeters. That is the length of B to C. I should have written it here. So therefore, to work at A to B, I need to do A to C, which is 6.15, minus B to C, which is this one here we just worked out, 4.1. And the answer to that is 2.05 centimeters. And that's how you answer question 21. Next question is question 22. Question number 22 is a question on compound interest. Right, first thing I want to do is to work out the multiplier for this bank, for which gives this interest. So in order to do that, you know how to do the multiplier. You do the original percentage, which is 100%, and you add the increase or the interest or the compound interest, which is 2%, and I give you a total of 102%, which is out of 100, and convert it to a decimal number, and that is your multiplier. Let's do the same thing for secured bank. In the year 1 in the secured bank, the interest is 4.3, so the multiplier was going to be, if we do it a bit quicker, it's going to be 1.043 using this method. And then in year 2 we have another multiplier, which is 1.009, again using this method. So we're going to multiply it by 1.009. So that is the first year. This is the second year, and the third year is the same as this one, 1.009. So you can see if you did the calculation in this one, you will get, going back to personal bank, we have the multiplier, which is M, and that is the same multiplier applied in the second and the third year. So we have to elevate it to the power of 3. Okay, and when you do that, so you get 1.061208, and the secure bank you get 1.06185, and so on. So you can see clearly the secure bank is the one that give you a better deal, okay, or give you best interest or better interest. So just write down a secure bank. Okay, and the working out is there. So next question is question 23. Question 23, we have a number that is rounded to 2 decimal places. Then the result is 4.76. We want to write it as an inequality. So we need to find the lower bound and the upper bound for this number. In order to do that, draw a number line, place your number. It doesn't have to be to scale, of course, and because it was rounded to 2 decimal places, so the digit that changes is this one here, the second digit, 1, 2 after the decimal point. So the one number before it will be 4.75, and the number after it will be 477. Now go ahead and find the midpoint. That number is 4.755, and that number would represent the lower bound. Do the same thing on the other side. Find the midpoint of these two numbers, and that number is 4.765. That number represents the upper bound, and you can write it down now as n less than 4.765 greater or equal than 4.755. 5, 5. Notice we have an equal sign here. We don't have an equal sign here. And that's how you do it. Next question is question 24. This equation, or quadratic equation, may be factorizable. We may be able to factorize it. Let's try. So we can write it as x, bracket x, bracket x equals 0. Now for the sign, we know it stays a minus 24, so it has to be a plus and a minus. Go ahead and write it down. Doesn't matter which order. Now I need two numbers to multiply to give you 24 and add up to 5. I can think of two numbers. 8 times 3 is 24. And when you do 8 minus 3, give you 5. So it has to be minus 3 and positive 8. Okay, so that's the answer. Now we need to go and solve it. Basically, in order for this to be equal to 0, you could have either the first bracket x plus 8 equals 0. That will give you x equal minus 8. Or the second bracket, x minus 3 equals 0. That gives you x equal 3. And that's how you answer it. Next question is question 25. This is the last question on this paper. Here we have a question on sequences. So we got 3, 8, so that's the difference of 5. So basically add 5. From 8 to 13 is also add 5. And same thing here, add 5. So you can see the difference is always add 5. Now, the first part of the term expression would be 5n because the difference is 5. Now, how do you find the number that comes after this? Because usually expressions of a sequence will be of this form, an plus b. We got an, this one here. We need to have plus b. Mind you, b can be anything, positive, negative, can even be a decimal number. So here's one trick you could use and it works all the time. Go back one step, so therefore you do minus 5. Minus 5. So you do 3 minus 5, that gives you minus 2. So the answer is going to be 5n minus 2. And that's how you do it. Question B, asking us to check whether 144 is part of this sequence. You could do it two different ways. You can replace n by the value of 4, because Nathan says that the fourth term is 144. So you do 3 times 4 squared and check whether they give you 144. Well, does it? You do 3 times 16, which is not, clearly it's not. So the answer is no. So with this question, we finish paper 2 of the 2017 Foundation tier. Next paper will be this one, paper 3, of the same year, 2017. Till then, take care. Thanks for watching.